Okay class, now we'll do question number 5. So in this question they've given sine ax plus b divided by cos ax cx plus d. So let us consider y is equal to sine ax plus b by cos cx plus d. Now differentiating both sides with respect to x, we get dy by dx equal ddx of sine ax plus b by cos cx plus d. So here we have to differentiate these two functions. So let us consider u is equal to sine ax plus b. Then we'll differentiate both sides. So we'll get du by dx equal ddx of sine ax plus b. So when you differentiate ddx of sine x, so here your x is the bracket part ax plus b. So when you differentiate sine x, you will get cos ax plus b into ddx of this bracket part ax plus b. So we'll get cos ax plus b into this ddx of ax will be a plus ddx of b is constant term, so it will be 0. So we'll get a cos ax plus b. Now let v is equal to cos cx plus d. So again we'll differentiate this with respect to x, so we'll get dv by dx equal ddx of cos cx plus d. So now we'll differentiate this cos x. So when you differentiate cos x, we'll get minus sine this bracket part cx plus d into ddx of this bracket part cx plus d. So we'll get minus sine cx plus d into ddx of cx will be c plus ddx of this constant term is 0. So we'll get minus c sine cx plus d. So therefore dy by dx will be ddx of, we have considered sine ax plus b as u and then cos cx plus d as v. So in place of sine ax plus b we'll write u, and in place of cos cx plus d we'll write v. Then we'll differentiate. Here we'll use the quotient rule. So that is ddx of u by b will be v into du by dx minus u into dv by dx divided by v square. So now we'll put the values that we have got. So v is cos ax plus d into, and then du by dx is a cos ax plus b minus u. U is sine ax plus b into dv by dx. dv by dx is minus c sine cx plus d whole divided by v square. So v is cos cx plus d, so you can just make it whole square, cos cx plus d whole square. After that you can arrange it. You can write a cos ax plus b into cos cx plus d, and this minus minus will become plus, and c sine ax plus b into sine cx plus d whole divided by cos cx plus d whole square. Okay. Now we'll do question number 6. So you have cos x cube into sine square x to the power 5. So here also same thing, we'll consider let y is equal to cos x cube sine square x to the power 5. So now differentiating both sides with respect to x, we get dy by dx equal ddx of cos x cube sine square x to the power 5. So let us consider u equal to cos x cube. So we'll differentiate both sides with respect to x. So we'll get du by dx equal ddx of cos x cube. So when you differentiate cos x, you'll get minus sine x cube, and then you have to differentiate this x cube. So you'll get ddx of x cube is 3x square. So you will get minus 3x square into sine x cube. Now let v is equal to this second part, sine square x to the power 5. So this sine square x to the power 5 we can also write it as sine x to the power 5 whole square. So now we'll differentiate both sides with respect to x. So you'll get dv by dx equal ddx of sine x to the power 5 whole square. So when you differentiate this, you will get 2 sine x to the power 5 into this ddx of sine x to the power 5 will be cos x to the power 5 into this bracket part x to the power 5 will differentiate. So we'll get 2 sine x to the power 5 into cos x to the power 5 into this ddx of x to the power 5 is 5x to the power 4. So we can multiply this 2 into 5x to the power 4, that is 2 5s are 10, x to the power 4 sine x to the power 5 into cos x to the power 5. So therefore our dy by dx will become ddx of u into v, because we have considered cos x cube as u and then sin square x to the power 5 as v. So in place of that we can write u into v. So here we can use the product rule. So we'll get u into dv by dx plus v into du by dx. After we'll just put the values. So u is cos x cube into dv by dx is 10x to the power 4 sin x to the power 5 into cos x to the power 5 plus v is sin square x to the power 5 into du by dx, and then du by dx is minus 3x square sin x cube. So we'll just arrange this. So we'll get cos this. Okay, so here you have 10x to the power 4 sin x to the power 5 into cos x to the power 5 into cos x cube. Then this plus minus will become minus, so we'll get 3x square sin x cube into sin square x to the power 5. So now we'll do question number 9. Prove that the function f given by f of x equal to mod of x minus 1, where x belongs to r. R is a real number. It's not differentiable at x equal to 1. So here in this question you have to prove that this modulus function f of x equal to x minus 1 is not differentiable at x equal to 1. So given we have f of x equal to mod of x minus 1. So wherever there is a modulus function we have to write like this. First we'll consider x minus 1 if x is greater or equal to 1. Next is minus of x minus 1 if x is less than 1. So now we'll check whether the so now we'll check f of x is differentiable at x equal to 1 if LHD. So LHD means left hand derivative is equal to right hand derivative. So if the left hand derivative and right hand derivative are equal, then we can say that the function is differentiable. If they are not equal, then we'll say that the function is not differentiable. So first we will find left hand derivative. So this is the formula for left hand derivative. Limit h tends to 0 f of x minus h divided by h. So we'll get limit h tends to 0. So we're checking for x equal to 1. So in place of x we'll write 1. So it will be limit h tends to 0 f of 1 minus f of 1 minus h divided by h. So next line, limit h tends to 0. Now you see f of 1. So when your value is 1, when the value of x is 1, the function is x minus 1. That means in place of x we'll put 1. So it will be 1 minus 1 minus f of 1 minus h. 1 minus h means less than 1. So we'll put the function where the value of x is less than 1, that is minus of x minus 1. So here also we'll put minus 1 minus h. In place of x we'll put 1 minus h, then minus 1. So after simplifying we'll get 1 minus 1 is 0, and this part if we simplify we'll get minus h. So we'll get limit h tends to 0, 0 minus h by h. So next will be limit h tends to 0, 0 minus h is minus h by h. So you can cancel h and h, you will get minus 1. Now we'll check the right hand derivative. So the formula for right hand derivative is this one, limit h tends to 0 f of x plus h minus f of x by h. So here also same thing, we have to check for x equal to 1. So in place of x we'll put 1. So we'll get limit h tends to 0 f of 1 plus h minus f of 1 by h. So next, so f of 1 plus h. 1 plus h means more than 1. So we'll take the function where the value is more than 1. So that is x minus 1. So we can write like this. You have x minus 1. So we'll write 1 plus h and then minus 1. In place of x we're writing 1 plus h and then minus 1 minus f of 1. F of 1 means in place of this when x is equal to 1. So we'll put 1 minus 1, that is 0. So after simplifying we'll get limit h to 0 h by h. So you can cancel h and h, will get 1. So as you can see, left hand derivative we got minus 1 and right hand derivative we got 1. So since left hand derivative is not equal to right hand derivative, therefore f of x is not differentiable at x equal to 1. And question number 10. Prove that the greatest integer function defined by f of x is equal to x. This square bracket, it means this is the greatest integer function where x lies between 0 and 3 is not differentiable at x equal to 1 and x equal to 2. So we have to check that there is a given function. We have to prove that this given function is not differentiable at these 2 points, x equal to 1 and x equal to 2. So we'll check it one by one. So the given function is f of x equal to mod of x. So at x equal to 1, we'll check the left hand derivative. So here we'll use the same formula, limit h tends to 0 f of x minus h by h. So equal to limit h tends to 0. So we're checking at x equal to 1. So in place of x we'll put 1. So it will be limit h tends to 0 f of 1 minus h by h. So now f of 1. So in the greatest integer function that is given, it's x. So in place of x we'll put 1. So it will be 1 minus, and here also in place of x we'll put 1 minus h. So we'll get limit h tends to 0 1 minus bracket 1 minus h. So since it is the greatest integer function, so the value of 1 will be 1 only. Okay, and then minus 1 minus h. Okay, 1 minus h means less than h. For example, if we subtract 0.001 from 1, we'll get a number which is less than 1. We'll get 0.9 and something. So that we have to take only the whole part, will not take the decimal part. So 1 minus h will be 0. So 1 minus 0 by h is 1 by h. So limit h tends to 0. So 1 by 0. So 1 by 0 is not defined because you cannot divide by 0. So now we'll check the right hand derivative. So here also we'll apply the same formula like we have applied in the last question. So you have limit h tends to 0 f of x plus h minus f of x by h. So here also in place of one more line we have limit h tends to 0 f of 1 plus h minus, in place of x we'll put 1. Okay, so we'll get limit h tends to 0 now 1 plus h. So in the square bracket we'll put it 1 plus h, that is the greatest integer function, minus f of 1 is 1. In place of the square bracket x we'll put 1 divided by h. Now you see here you have the greatest integer function, in bracket we have 1 plus h. 1 plus h means, say 1 plus h is a very small number, say 0.1. So you'll get 1.1. Okay, if you take 0.001 you'll get 1.001. So greatest integer function means we have to take only the integer part, we will not take the decimal part. So it will be 1 only, minus, and for 1 it is already 1. So 1 minus 1 is 0. 0 by h is 0. So as you can see, the left hand derivative is not defined and the right hand derivative is 0. So they are not equal. So since left hand derivative is not equal to right hand derivative, therefore f of x is not differentiable at x equal to 1. Okay. So and the second question, you have x equal to 2. So this I'll leave it as classwork, you do it by yourself. Okay, you have to check that at x equal to 2 the function is not differentiable. Thank you.